Welcome back again. I am Johannes. Today I will proceed liquid containers subjected to constant vertical acceleration. So let us see. A cubical water tank of size 2 meter contains water to a depth of 1.5 meter. Determines the force acting on one side of the tank when it is accelerated vertically upward at 5.5 meter per second square. So this is acceleration, and when it is accelerated vertically downward at 5.5 meter per second square. So we are given that length, breadth, and depth of the tank 2 meter because it is cubical, and h you have 1.5, something 50 centimeter below the rim of the tank, which is this one. So acceleration is given 5.5 meter per second square. So just you can see an element, just a fluid element, which is just free body diagram. You can check this one, which is this value. If you have h distance for this element, then you have P times dA at the bottom of the fluid element, and the weight of the fluid element is going down. So pressure force on element, which is this one, pressure force on element minus weight of an element, which is W, is equal to mass times acceleration, according to Newton's second law of motion, or summation of force in y direction equal to 0. Then you can equate now. So you have you have weight of element. Weight means gamma times V, which is this one, rho g, which is unit weight, and volume is h times dA, because you have h and you have dA, elemental area, at the bottom of the fluid element. Then you can just see HdA, which is gamma times volume. This is total weight of element. Then mass times acceleration in y direction. So acceleration, you can just calculate now. So rho HdA, which is mass of an element, because you can see density is mass over volume. So you see just mass, you can compute density times volume, which is mass times acceleration times y. So just you can take out this one, dA, just common factor. You can take from here dA, then dA will cancel out. So dA, you can cancel out dA here, cancel dA, cancel dA, cancel dA. Then, or you have this equation, general equation. You have this equation after cancelling. You have this equation. Then you can take out rho gh. Rho gh, you can take out rho gh. Then to make this one a over g. So a over g, because g will cancel out. Then this will give you this result. So when the tank accelerates upward, the pressure intensity is given by this equation. So this is the pressure intensity for upward motion. So you can use this equation. So you can calculate now just the density of water times G times 1.5 H of water, then 1 plus 5.5 over 9.81. So you get this result, which is the pressure when the tank is accelerated upward. So you have pressure increase due to upward motion. Due to upward motion, you have pressure increase due to this region. So initially you have rho gh due to this height. You have at the bottom you have rho gh, but due to increment you have this region. It will go from Q to R total base, which is P. So this is just the additional acceleration in y direction over g. So you get this result. So force on the side PQ, this side, what force is exerting on this side? So you can compute again. Force is equal to average pressure times area of contact, area perpendicular to this. So average pressure is 0. At the top you have 0. At the bottom you have rho gh already. We computed this one. Total pressure you have, then you add over 2, then times area. Area is 1.5 times 2. So you have 1.5 depths of water times 2 meter, 2 meter on the other side. So you get, this is the force. The force exerted on side PQ. So when it is accelerated upward. What about when the tank accelerates downward? When the tank accelerates downward. So the pressure intensity becomes just due to downward motion. So it will go, just acceleration is decelerating. Then from rho gh, initial rho gh you have, but finally it will come to P. So rho gh 1 minus acceleration y over g. So you get this result. So this is a pressure decrease. This region will be a pressure decrease. Initially you have rho gh up to this point, but due to downward motion, it will increase to P. It will increase to P because H is decreasing. So I think you have the same approach, just force on one side PQ, average pressure times area, then just you add 0 and this value, total value, then you have this P, this region, then 0 plus 6,465 over 2, then get this result. Then finally, this is the force on side PQ when the tank accelerates downward. So as a remark, when a tank containing a liquid that accelerated vertically upwards, the surface of the liquid will remain horizontal. But in particular case, if the tank is accelerated downwards with an acceleration equal to the acceleration due to gravity, which is g, then ay equal to g, then p will be 0. The pressure at all points will be atmospheric if the acceleration is equal to acceleration due to gravity. Thank you very much. If you have questions.